Okay, uh, welcome everyone to today's webinar about prototyping and 3D printing. So I hope that you have been joining with this webinar series that we have conducted under uh, the Future Founders program, which is done as a collaboration of SLESA and SLIIT. So this is the last webinar that we conduct under this webinar series. So I hope that you have been enjoying the content that we delivered and you have learned. So I'm Samadhi Rathnayake. I'm a lecturer attached to Faculty of Computing, Sri Lanka Institute of Information Technology. So today's session will be done by myself. So here the information about myself is given. So if you have any kind of a doubt or anything regarding this webinar or any kind of further help, you can contact me anytime. Right. So as I have already mentioned, under the SLESA Future Founders program, we have conducted several programs, several sessions. Under that, we conducted a session for the low-code and no-code programming and introduction to artificial intelligence and machine learning and web development. Actually, web development webinar was done in two different sessions. In those sessions, actually, front-end development, back-end, and database handling, those areas were covered. And then a very comprehensive webinar was done for the basic electronics and Arduino programming. And then finally, last week, actually, we conducted a webinar to the introduction to robotics. So this is the last webinar, last program we conduct under this webinar series, the rapid mechanical prototyping with 3D printing. So in today's session, actually, we'll be covering the concepts of the prototyping. So why the prototyping is important, what are the different types of prototyping, the different versions of the prototyping, and then we'll move to the main focus in today's discussion, which is the mechanical prototyping, and then we will talk about different ways of performing the mechanical prototyping, and finally we'll introduce the 3D printing. And I have a kind of a surprise for you as well, right? So I will tell you what is that surprise at the end of the webinar, right? Okay, right. So let's start with the discussion, and I very kindly request you to mute your microphones within the duration, because it will help everyone to make a focus in a good way to this session. Right. So let's start today's webinar about prototyping and 3D printing. Right. So first of all, we'll have a kind of idea about what is prototyping. What is it meant by the prototyping, right? So first, so when we talk about the prototyping, right? So basically, prototyping means, right, kind of a, it can be kind of a software or it can be kind of a physical product, right? So let's think that we are going to develop kind of a software or a physical product, some kind of machinery, some kind of equipment, right? So before we actually proceed into the real environment to use it really, right? We want to check whether this particular developed item is basically viable, or let's say, is it working? Is it working fine, right? Is it working fine? Okay, because of that particular objective, we use a concept called prototyping. So basically, prototyping means turning your idea into something real you can see, right? You can see. Basically, it can be something which is just visible, or it can be something tangible. Even we can just touch it and basically use it at work, check whether it's working, and test. For an example, just think about that you are going to make a kind of a simple backpack, let's say with a kind of a hidden pockets to let's say to deliver as a kind of a, let's say, kind of product to the market. So before you actually deliver it, it's better to actually check that particular sample version of the backpack, let's say with the hidden pocket. So, and then we can check whether it's actually working, whether it's actually viable, right? Like that. So that is what basically the idea of a prototype, right? So it can be, as I have already mentioned, it can be something which is created for a software or a physical product, right? So we'll discuss about these stuffs step by step. So as I have already mentioned, so here I have very simply defined the concept of the prototyping. So basically a prototype is an early version of your product to test the design. So there are different reasons. We'll discuss them later as well. It can be used for testing the design or the functionality or the style of whatever the product, right? So as I have already mentioned that it is actually helping us to check whether it's working fine. That is the most important thing, because that whatever the software or a product is, let's say if it is not working according to our requirement or according to our plan, our product is failed. So then we have to make sure the product is basically working fine. So then that is the most important part. So that can be satisfied with this particular prototyping mechanism. Another thing is we have to check whether it's, what about the visibility of the product? In other words, the interface, the UI, right? So basically how it looks, right? That is a very important thing, because it gives you kind of impression to the whatever the person who is going to use it, right? So then that can also be checked. So why do we check them? What is the reason? Because that before we deploy it to the real environment, we can check whether it's working or whether it's fine with the functionality or the design, whatever the thing, and we can improve them, right? We can improve them because uh, let's say that we have released it with some kind of a defect. So sometimes it may be, right, it may be a kind of a big problem, because we can't control when it is in the production level, right? So the most important thing is, right, right, so we are going to test, right, these prototypes before spending lots of money making, right, lots of money making the final product, right? So basically you know that without testing it, let's say if you have released it to the production, and let's say if you have spent lots of money to build your product, or let's say lots of time, or let's say it can be cost, human resource, whatever thing, for building a product, but let's say if that product is having kind of a problem, then you are in trouble, right? So that is the most important actually purpose of actually building this product. So I have already mentioned prototyping is the product process of creating a sample version of your product. So it actually helps you spot flaws earlier, and it will save the time, money, and effort, because it will allow you to, right? It will allow you to improve it further, right? By checking the things, right? So I have been discussing about these use cases, or these the value of building the prototypes. So already I have discussed, but uh, I just very simply explain them again. It will actually allow you to find the design or the functionality problems earlier, and it will actually save the time and money, right? And most important thing is, sometimes it can be taken as a feedback process about your product. You can just allow, so not just actually developing a kind of a simple version. You can basically allow this particular product to be used by, let's say, a few set of customers, or let's say whatever the users, and it will actually give you kind of a feedback, right, which will important for improving your product. That is another thing, right? So for an example, let's say if you have a kind of a shoe company, right, you can basically, if you have built a kind of a shoe, you can basically test it, right, the comfortability, the usability, the durability, right? The strength, everything, right? By allowing this product to be used by the real customers or set of users, and then it will actually give you a kind of a feedback about your product. So it will definitely help you to improve your product further, right? So these are the basically the concept of prototyping. Basically, prototyping means you are just going to build some kind of a product which is right, which is uh, not the actual product, but we normally call that particular product as the minimum viable product, right? Because it is not having all the functionalities or all the features of the product, but it is just a kind of a sample of the product, a kind of early version of the product, which is giving you kind of an idea about the product. So basically, uh, the main purpose is to test the product, right? So if the product is good, then we can improve it further. Or if the product is having some issues, we can actually uh, test it and try to avoid the problems, right? Now, let's see what are the different types of products, different types of prototypes. Sorry, right? So as I have already mentioned, these prototypes can be created not just for the physical things, even for the software, right? So basically, we can identify there are mainly four types of prototypes, right? The first type is called as, guys, concept prototype, right? Second type is called as functional prototype. Third type is called as digital prototype, and finally it is mechanical prototype. That is what actually we are going to focus mainly in our discussion today. But we'll have a kind of understanding about these first three prototyping mechanisms as well: the concept prototype, functional prototype, and digital prototype, right? So what is meant by the concept prototype? So in simply, right, in simply, I have mentioned here, right? So it's basically focusing on the design, shape, and the style of the product, right? Functional means it's checking whether the particular product is working. It's basically focusing on the functional component only, right? Digital product means rather than just focusing about just the design or the functionality, we take kind of a full product as a uh, initial version, and it includes both the design and the functionality, but it's a software-based thing. That is what the digital prototype means. It can be, let's say, a software app or a simulation likewise. And finally, the same thing we are going to do with the physical way. We'll learn, right? We'll learn why these things are important and what these are means. So first, we'll go with the concept prototype. So I have already mentioned it's basically focusing about the shape, design, and the style, but not the functionality. Very important. For an example, let's say if you are having kind of a car manufacturing company, right? So if you want to, let's say, get an idea about the design of the car, you can just use, let's say, some clay, or let's say some kind of a material, not to actually check the basically the functionality, but to check the uh, physical, or let's say the visual output. It can be just built with the clay likewise, right? So so I have mentioned the value of these concept prototypes. Basically, it is allowing you to check the different designing techniques, right? And it is allowing you to actually check the dimensions of the product. So how big this particular product is, how this particular is this particular size of the product is sufficient. You can check some kind of idea. These are visual things, and it is again giving kind of a way to get the feedbacks bit earlier about the aesthetics of the product. Aesthetic means basically the visual things, the design, and the dimensions likewise. Some examples are given here. I have already mentioned, let's say, you can just, if you have a kind of a car company, you can build, let's say, clay models to the new vehicles just to get some kind of idea about the design. And if you have a kind of a mobile phone kind of a company, you can basically, let's say, create some dummy units and test the size and the comfortability of whatever the, let's say, mobile, something like that. And let's say if you are, let's say, kind of a fashion designers, you can basically create some mock-ups of clothing to get an idea about the visual output of the whatever the product. Likewise, so these are the things that you have to understand about the first type of prototype, which is the concept prototype, right? Right. Next, we'll go to the functional prototype. So as I have already mentioned, in the concept prototype, what we basically focus is just the design of the prototype, basically the design, right? So functional means we don't focus about the design, we focus about how it works. That's what basically focus about the performance of the whatever the software or a physical product. We don't think about the visual design. That's not a main focus here. We just focus about the functionality, right? Right? Okay. So we don't care about the look actually, right? It's the second part. We just focus about the functionality. So as I have already mentioned, right, it is allowing the engineers to validate the process or the mechanism, right? Mechanism of whatever the right product, and it can be validated, and we can just identify is there any kind of a technical issue, right, in this particular functionality. If that is there, we can just fix it, right? And you know that when we have a kind of product, the functionality actually is allowing us to uh, identify the features of that particular product, whether this particular feature is working. So it's actually giving kind of a demonstration about the features, but we don't actually put all the features here. In the functional prototype, mainly we focus about the basic features. For an example, let's say if it is a mobile phone, we check whether you can get the calls from the phone. That's the thing, not the fancy things. If it is a camera, we check whether it can be taken to capture the things, something like that. Understood? So basically, that is what the functional prototype is. I have just given some examples as well for your understanding here, right? For an example, let's say a robot arm prototype. Let's say you can just create with the 3D printed parts, but we can check whether this particular arm is working. We don't care about the design. We focus whether this particular arm is, let's say, moving, right? Can it be changed the position likewise. And let's say a wearable device prototype, right? We can check whether the sensors are working fine, right? And let's say a machine part, let's say a kind of vehicle or something like that, we can check whether it's moving. Understood, guys? So like that, we have different, right? Functional checking we can do with these functional prototypes. Right now, right? We discussed about the concept part and the functional part, right? You know, this thing can be actually this particular designing thing or the functional thing, both can be discussed about both software based productions as well as hardware based productions. We can use these prototyping for both. So what we discussed in the conceptual case was just the design. Functional case was just the functionality. So when it comes to software based production, digital prototyping means the combination of the conceptual and the functional prototyping, but especially under what? Under the software-based products. That's very important, right? So it can be a software, it can be an application, or it can be kind of a simulation. So it's basically kind of a way of, right, checking whether this particular software is working fine. That's the thing. So the examples are given here. Let's say it will allow the user to test the particular user experience and the user interface both together. User experience means basically the functionality, right? So user interface means basically the design. So both can be, right? Both can be tested, right, with this kind of digital prototype. And it will simulate the performance under the different conditions. For an example, let's say if it is kind of a operating system or something, we can check, guys, that how this particular operating system, the performance is basically given in different memory capacities, right? Different, let's say uh, power supplies, and then different things we can just identify, right, whether this particular product is working. And let's say if it is kind of a product which is connected to the internet, we can check, right? So when the internet traffic is very high, internet traffic means basically the speed, let's say speed is, let's say, very high, or let's say very low, right? If the traffic is high means, speed will be very less, right? So like that. So if you have that kind of a case, then how this particular product is working like this. And it will actually visualize the product using the 3D software. For an example, if I talk about, so we don't discuss here about the software based prototypes, but for the software based prototypes, we have a very nice tool called Figma, right? It's a very nice tool. It's called Figma, right? Figma. You can just check them. So that's kind of way actually we can just visually show, right, how my product looks like. And even we can just connect different interfaces to each other and see how these are getting communicated together. Likewise, right? So like that, we can just identify different right, different connectivities and the functionalities and the user interface, everything about the digital product using this digital prototyping. I hope you got my idea, right? So now I have just given some examples as well, right? I have given some examples as well. So let's say mobile app wireframes or interactive app demos. Wireframes means basically wireframe in the sense, let's say if you have a application, let's say a kind of a mobile app, there are different pages. When you click a button, it will give you a new interface, another interface. Let's say if you have 20 interfaces in your app, those are called as wireframes. That is what actually I just talked about, that Figma. So Figma actually is used for, right, showing the wireframes as well as how these wireframes are getting connected, and architectural 3D models of the buildings, and simulations of aircraft parts under the stress. Likewise, so different right, um, examples we can actually discuss under this um, prototyping. All right, now this is the thing that we are going to focus in today's discussion, mainly mechanical prototyping. What is this? What is it meant by the mechanical prototyping? Right? We discussed about the concept prototyping, functional prototyping, and then we discussed about the digital prototyping. Now, I hope you may be having kind of a hint about this thing, right? So basically, what I have given as a slogan for this particular slide, the bringing the ideas to the life physically. That's the thing, right? Physically, we can see the things. That means what? Software prototype or the digital prototype is just a thing that we can't touch, right? But this thing you can't even touch. It's tangible, right? That's the thing. That's very nice. And not so now you may be thinking, okay, what's the difference between that clay car and this one? No, that clay car actually was just built to get an idea about the design. But this is not just a clay, right? Here, all the functionalities of that car is also there. But a kind of a, right, initial version of that. That is what the mechanical prototyping means. A kind of initial version of a physical product, right? Now, this is very interesting. because you can touch it, you can work with that, right? All right, I have mentioned here, right, what is the mechanical prototyping means. So basically, it is building the real models with machines to test the shape, comfort, and the strength as well as the functionality. All right. So I have mentioned, right, the usages of this mechanical prototyping. So as we already learned, it will actually allow you to validate the structural integrity and the durability of the product. And it is basically allowing you to the movements of the parts and the mechanical assemblies, and it will basically ensure the component compatibility, whether these components are getting fitted together correctly, and it will actually allowing you to identify the design flaws before the production, and it will definitely reduce the risk of costly manufacturing errors. That is very, very important. It's kind of a physical item that we can work with, right? I hope you got my idea, right? So now you may be having, I know that you may be thinking, right? Oh my God, if you can bring a kind of a physical version of some kind of a conceptual product, or let's say some kind of product that you are going to give to the society, if you can bring some kind of a physical thing, how can we build it? I know that you guys are thinking about that. So guys, I have here mentioned, right? I have here mentioned some different prototyping mechanisms, right? So one of the very, very popular, right, very popular mechanism of building these mechanical prototype is, guys, 3D printing. That is also called as additive manufacturing. Additive manufacturing, right? So this is a kind of a main focus in our program that I'm going to do today, right? So this is what actually we are discussing mainly in this particular session. But so then we'll discuss about this 3D printing, or in other words, this additive manufacturing, this particular mechanism bit later. But before that, guys, I'll give you a kind of a brief idea about these right other parts, basically CNC machine and laser cutting and sheet metal fabrication and material testing and assembly prototypes, right? So we'll have a kind of understanding about, right, understanding about these small areas first of all. So first of all, guys, the CNC machine, CNC machining, what is this means? So I think you have seen, guys. So there are some cutting machines, right? So in the very large scale manufacturing, right, organizations, right, um, the workshops, you may have seen, right, these CNC machines are, there are different CNC machines. So basically, these machines are cutting. What they are mainly doing is cutting, right? They can cut. Let's say it can be some kind of a wood, it can be some kind of a metal, or something like that, right? So basically, we physically cut it, right? All right. So I'll show you kind of example about this CNC machine mechanism. And the same thing can be done in a different way. We call them as laser cutting, right? So there we use the laser waves, and with that we can cut, right, uh, the things. Especially we use this laser cutting for the metal base, right, objects. So I think that rather than just discussing about this one, I hope you will be getting a kind of a good idea, right? A kind of a thorough understanding about this CNC machining and the laser cutting with some real videos, right? So I hope that you can just even search them in the YouTube as well. But just to give you kind of a interesting points, as well as just get some kind of a idea, I'll just show you a few videos about these CNC machining and the laser cuttings. Give me 1 minute, guys. Right. I hope you can see my screen. So this is kind of a YouTube video which is showing you how these CNC machines. You can see that here we have a kind of a wood object, right? So we'll see that how this particular object is built. Now I hope that you saw that what happened, right? So this is what is called as a CNC machine, right? I'll show you more videos. Give me 1 minute. Right, so this video I'm going to show you again. This is a YouTube video, so I'm going to show you about the CNC machining. Especially, I'm going to here. This video actually is giving an idea about different types of CNC machining, right? So let's go with that. Right, so this is giving you kind of idea about different types of CNC machining. This is kind of a way of getting a very good understanding about the CNC machining, right? Okay, just look at this.
Welcome to Yijin Hardware's channel. Have you ever create those highly precise components? It's all about CNC machining. In today's video, we'll take a deep dive into the different types of CNC machining, explain how they work, and highlight their unique applications. Let's get started. What is CNC machining? CNC, or computer numerical control, machining is a technology-driven manufacturing process that transforms raw materials into precise parts. With computer-guided controls, CNC machines offer unmatched precision, efficiency, and repeatability, making them essential across many industries. Types of CNC machining. CNC milling. CNC milling uses rotating cutting tools to remove material from a workpiece. This process is ideal for creating complex 3D shapes or parts with tight tolerances, like molds, aerospace components, and automotive parts. It excels in creating intricate designs that require precision. CNC turning. In CNC turning, the workpiece rotates while stationary cutting tools shape it. This makes it perfect for cylindrical parts like shafts, bushings, and threaded components. Whether you're working with metals or plastics, turning ensures smooth finishes and high accuracy. CNC drilling. CNC drilling specializes in creating holes with extreme precision. From tiny apertures in medical devices to large bores in industrial machinery, this process focuses on accuracy and consistency to meet the highest standards. Wire EDM, electrical discharge machining. Wire EDM uses an electrically charged wire to slice through conductive materials. It's perfect for producing intricate shapes in hard metals, such as aerospace turbine blades or high-precision dies. With its ability to cut through hard materials, it's invaluable for industries requiring extreme detail. Other specialized machining processes. CNC machining also includes specialized methods like CNC laser cutting and CNC plasma cutting. These are great for cutting materials quickly and efficiently, offering solutions for both thick and thin materials. While CNC milling and turning are the go-to methods for many machining tasks, specialized techniques like wire EDM and drilling serve very specific needs. For example, milling is fantastic for creating molds and aerospace components, while turning is essential for cylindrical parts. With its versatility, CNC machining serves industries as varied as medical devices, automotive, and aerospace. CNC machining offers endless possibilities, from precision to versatility.
So I hope you got a very good understanding about different types of the CNC machining, right? So it's kind of way of cutting, right? Cutting the objects. So and again, we can just get some kind of a a kind of idea about, right, a kind of a big product by getting a kind of physical, right, item. Right now, I mentioned that that CNC machining. So it's one of the mechanism of basically it's really cutting, right? So it has a kind of enhanced version of, I think that in the video also it mentioned laser cutting, right? So basically we use the laser beams to cut, especially the metals, right? So let's have some kind of idea about that as well. So this video actually is giving you an idea about this laser, right? Laser-based cutting. All right, I hope you got an idea about that as well, right? This is how, guys, that basically these right, CNC and the laser, right, base cutting thing happens. So let's come back to the lecture note. Right. So now I think that you have a kind of good understanding about, right, what these first two mechanisms are. So now the first two, that second and third one. So first one we are going to discuss later. That's why I didn't mention it now, right? We'll come to that one later, because that is one of our main focus in our today's session. Last one, guys, basically material testing and assembly prototype means, we can, that rather than just focusing about the design, the shape, here we focus about the needed material in that particular product as well. So we can identify the needful materials for that particular product, and you can just step by step. Assembly prototyping means you just create different parts and combine them and get a kind of a viable product at the end of the assembly. So these techniques can be actually used for used under this mechanical prototyping, right, to get a kind of a minimum viable product, right, especially if you want to see some kind of idea about, if you want to get some kind of idea about your original product. Right now, guys, we'll start discussing about our one of the main focuses in our today's discussion, which is 3D printing. Very important. 3D printing, right? So this is what, right? You know, I have given a slogan here, shaping the future layer by layer, right? What is that, guys? All right, this is what, guys, we are going to mainly focus in today's discussion. So what basically happens is, right, it is that the previous things that we saw, even in the laser cutting and even in the CNC machining, right, what happens was we mathematically, right, so mathematically we just write a kind of a program, all right, this is the place where we have to cut, and this part should be cut, and this part should be separated, this part should not be cut. Likewise, we have to mathematically write in a computer program. So based on the computer program, those machines are work. Understood? That's what happening. Now what happens is, guys, so then based on these machines cutting things, we can get kind of a product at the end of the process. But now what happens? This is actually more that, you know, in that CNC machining and the laser cutting thing, the things that we can't actually create any kind of a product with these mechanisms, because there are some cases you can't actually use these machines because they are basically depending on the cutting machines, right? Cutting machine එක අනුවනේ ඒ අපිට ඕන කරන හැඩේ ගන්න පුළුවන් වෙන්නේ. ඒ cutting machine එකෙන් හැම මේ අපිට හිතන ඕන දෙයක් කපා ගන්න බෑනේ. right? ඒක තියෙන විදිහට අපිට ඒක පාවිච්චි කරලා එහෙට මෙහෙට කරලා අපිට ඕනේ ගන්න පුළුවන්. That's fine. But you can understand you can't actually get any kind of prototype or any kind of shape with these machines. ඒ machine එක අපිට හිතුණු જાතියේ මේ ඒව ගන්න බෑ. You can understand it. Understood? This is a kind of a way if you want to get like that, right? If you want, let's say, get the things, let's say, if you want to get whatever the design as you need, right? 3D as a, let's say, a kind of a visual object. This is the way, guys. 3D printing. It's a very nice mechanism. It's a very joyful mechanism, guys, to actually discuss, as well as very you can see that here that the process of actually creating these basically that it's very nice to see. Actually, the particular process is very beautiful, right? So you will enjoy it definitely when this 3D printing is actually happening, really, right? So I'll show you some videos as well later. So, but you know, it's very beautiful to see. But guys, inside this particular 3D printing mechanism, there are lots of, right, lots of complicated things are happening, right? So that is what we are going to basically focus in this particular discussion. So as I have already mentioned, guys, in the 3D printing, right, what happens is we are adding the material layer by layer to make the real objects. For an example, that designing and printing a kind of a keychain at home, right? So basically we just create the 3D item, right? But that is not the actual item, right? Don't get misunderstood. That is not the actual item. It's kind of a 3D visual thing, right? So it is basically building a kind of a physical mechanism, right? By adding the material layers, right, and the design, and it will actually give you a kind of a really good understanding about how this particular product looks like and how we can actually work with, right, physically. Okay, so I have here mentioned, guys, the steps that you have to follow when you are building a kind of a 3D design, right? The first step, so we will learn about these step by step, these steps actually, right, one by one. But here very briefly I just mentioned about these steps, guys. The first step is designing this particular whatever the 3D, right, object, 3D prototype with a kind of a CAD software, right? So in today's discussion, actually we are going to use I'll show you. I'm going to demonstrate you how can we create a kind of a 3D object. We are going to use a very beautiful, very nice, user-friendly platform called Tinkercad. Right, Tinkercad platform will be used here in today's discussion. And but there are some more different types of CAD softwares. Right, give me 1 minute, dear student. Right, guys. So the first thing is basically designing, right? And the next thing is, guys, so although we have designed it, when this particular 3D item that we have designed is going to be built, actually, you can see that ගෙඩිය පිටින් එකපාරටම අර හදපු ඩෝංගාරිලේ නැහැනේ. තේරුණා? ඒ කියන්නේ දැන් අර දැන් අපි පටල ගන්න එපා රයිට්. අපි දැන් සාමාන්‍ය printing shop එකක මේ කොලයක් print කරනවා වගේ නෙමෙයි මේ 3D print එකක් කියලා කියන්නේ. රයිට්. අපි මොනවා හරි දැන් අපි මොනවා හරි කරනවා අපි ගෙයක් හැදුවා කියලා 3D print එකක් විදිහට. ඒ ගෙදර එකපාරට ඩෝංගාලා එළියට එන්නේ නැහැ. Understood? එහෙම එන්නේ නැහැ, right? එහෙම එන්නේ. It will be built step by step. It will not be directly given out as a single item, right? You will see when I show some videos. So it will be basically built layer by layer. Very important. Yeah, හැදෙන්නේ layers විදිහට. Layer by layer තමයි මෙයා හැදෙන්නේ. Understood? So how these layers are decided? That's the thing. That is again, guys, we need some software. After we have designed the full object with the CAD software, it should be splitted to small layers. අපි CAD එකෙන් හදුවට පස්සේ right 3D design එක ඒක කෑලි කෑලි වලට කඩන්න ඕනේ. Right, build කරන්න පුළුවන් විදිහට. That is also done using some right softwares are there. I'll discuss them right with you. And that is for the next process. How can we slice this particular 3D model into different layers? Third one is, guys, printing. That's it, right? අපි කොහොමද දැන් අර කඩපු ටික print කරන්නේ? Right? For that thing we need some materials. We'll discuss about those stuff. So using right different materials, using different machines, different mechanisms are there, different types of machines are there. With them, actually they are going to be printed layer by layer. Finally it will be getting connected to everything and finish your product. And it's not finished, guys. You have to clean it. Okay, ගත්තට පස්සේ ඔක එන product එක 100% හරි නෑ. You have to clean it, guys. You have to clean it, and sometimes you may have to add something after the process, right, guys? So we'll step by step discuss about these stuff. First we'll go with the first part of this discussion, guys. So basically designing, right, this thing with the CAD software. So you can see that I have already mentioned, guys, what this means. You are going to just basically create the 3D model on the computer using some kind of a CAD. CAD means the computer aided design, right? So I have here mentioned some examples, some tools as well. One of the tools is SolidWorks and Tinkercad and Fusion 360. Likewise, different platforms are there. So today I'm going to explain you guys, or I'm not going to discuss about, right? I'm not going to discuss about a very big project in this particular lesson because that we have very limited time. So here a very simple, very gentle introduction is given, right, about these processes. So then I just very simply I will explain, right, how to use this Tinkercad platform because it's a very user-friendly platform. So I will quickly come to this platform and then you will understand what I just mentioned here. So you can actually Google this Tinkercad, right? When you Google it, wait a minute, I'll just show it to you. Right? This is what actually you're going to take when you just search in the Google. So this is the particular link that you have to go, right? You have to go there. And then the thing is, guys, if you're actually going this for the first time, right, you have to basically create a kind of account, or you have to log in with your Google account, or otherwise that that like you are doing for any kind of any other, right, whatever the let's say website or a platform, you have to log into that one. මුලින්ම ඉතින් log වෙන්න වෙනවා. ඊට පස්සේ ඔයාලා ගාව account එකක් නැත්නම් sign up වෙන්න වෙනවා, right? Sign up වෙද්දී ඔයාලගේ details දීලා you can sign up, or you can just log in with your Google as well. Anyway, guys, though I'm not going to explain about how to log into this one. It's a kind of thing that's a very simple stuff. අපි සාමාන්‍ය log වෙනා වගේම තමයි, right? And then after we have logged it, guys, we'll be getting this kind of interface. So now I have already created my account. So this kind of a interface we can see. So this particular Tinkercad actually can be used not only for the 3D designing, guys, even this can be used for building some circuits, especially if you are working with some IoT based projects. You can actually use them, and some code blocks, right? Some different mechanisms are there. Lots of options are given here. Even these platform can be used for by the teachers as well. So there are lessons and the things, and even you can just create some classrooms inside this particular platform. So I'm not going to actually discuss about those stuff since these are not the main focus in our discussion. So I'm going to explain you how can we use this particular platform actually for building some 3D object. You can see that here I have already built some of these objects in my machine. So anyway, so I'm going to build a new thing now, right? You can just click this particular, let's say, create. You can see that here it gives you 3D design. So there are 3 options. I'm going to select this 3D design because I want to create a kind of a 3D object now, right? So now it will give you, right, this particular interface. And again, I'm just telling guys, I'm not going to actually demonstrate building a very big project here, right? This is a very simple, gentle, right, introduction. That's it. නිකම් පොඩි introduction එකක් දෙනවා විතරයි මේ ඔයාලට, right? So then you can actually, right, try these stuffs and get more idea about this. All right, now we'll create a kind of a very nice so the thing is, guys, this, you can see that here we have a kind of a surface, and this particular surface, you can see that here, right, even you can just select any place. So this particular box, you can see that here we have a box, guys. You can just move it here and there, and you can see this particular plane is changing. Top, front, right, left, back, bottom, likewise the things are there. Right, it's up to you, right? Let me just keep like this now, right? Hurry. Now, guys, the thing is this, right? Here we have different shapes, you can see, and even you can just select different shapes here. If you click this one, let's say, you can just create your creations. So these are things that I have already created. So basic shapes, letters and numbers, design starters, and some characters. Click around, you are getting some different characters you can take, right? So, and then design starters and vehicles, machineries. If you need, let's say, some different vehicle machineries, you can just click this more shapes like this. You can see that here it gives you, right, lots of shapes like this, right? You can get it, right, as you need, right? And then here electronic items, if you need, right, let's say you need to work with some, right, electronic items, you can just get them, right, for your need. And games and fun, basically like sports and those stuffs, you can just get with this, right? So like that, guys, you can just get different stuffs, right? So that's the thing, right? You can and even you can just search, guys, right? So if I need, let's say, if I search, let's say, a car, something like that, right? You know that here it gives you some of the, right, related things, right, to the car. Related. So whatever the thing, guys, right? So after you have searched it, right, it doesn't matter. So the thing is, now let's go with the basic shapes for now. So I can select, right, one shape as I need. So let me just select this one here. You can see, guys, when I click this thing, it gets like this way. So I can see it's very nice. It's like a very nice 3D, right, movement. You can see. I can just click it here. You can see, guys, it gives you, right, this particular object here, right? And the beautiful thing is, guys, you can just make අපිට මේක එක එකක් කරන්න පුළුවන් මේක මේ. Can you see? You can just change this size as you need, right? So ඕන මේක උඩට පහළට අදින්න පුළුවන් ඔහොම, right? You can see that here, right? We can just get like this. All right, now let's say I just got it like this way, right? So and even you can just move it here and there, right, as you need. Move around, right, as you need. So and even, guys, you can see that here, if you have keep it here, Eva, can you see? You can see this particular object, right? So how this particular object is visible in different directions, right? Different directions you can basically see, right? So now let me just get for my easiness, so I can just move it here and there. It's very simple, right? And then, right, you can basically right, let me just make it bit, right? So you can now get another different object and, right, connect with this. Let me just get this ball here. I just put this ball here, right? And I can just basically let's say ball, right, here and there as I need, right? So I can basically right, shape the particular shape. Things can be changed here as I need, right? So you can see that here, right, things can be, right, change as I need. So if I, let's say, check it like this, you can see it's like this. It's very nice. Can you see it, right? So and the thing is, guys, you can see that here, even you can see it can be just put into the 3D object. Now can you see that let's say සමහර දැකලා ඉතින් සමහරට box ඔය සමහර නිකන් අමුතු ලස්සන designs තියෙන්නේ නිකන් අර box එකේ නිකන් එහෙම එළියට නිකන් පොඩ්ඩක් නෙරලා ඇවිල්ලා වගේ. You can see it is this, right? You can just take it like this way. Here, right? You can just create it like this, right, as you need. So එක එක හැඩවලට දාන්න පුළුවන්, right? Even you can just see how it looks here, and you can see that here it's actually the some part of this thing is taken here. Even you can just put it here like this way, or you can just take it here, right? Can you see, right? Right, it's very nice, right? It's very beautiful, right? You can just create, right? You can see that here, right? Some part has been taken out, so I can just put it inside this, and even I can just take this part like this. All right, this part like this. I hope you got my point, right? So like that, can you see it's very beautiful, right? Okay, even I can just take another, let's say I take another ball here, and I'll just take it like this way, right? Change the shape. You can see it's very nice, right? Can you see it? It's a very beautiful object. Got my point, guys, right? So now there are some more different objects. I mean, let's say I want to just put this thing on this particular. So now I just go with this particular object. Let's say I just want to put this particular thing here on top of this, right? And if I check this one, you can see it's like this way, right? I can even change the direction or the place of this one. You can see, right? Right? Let me go all ගෙදරදී නිකන් කරලා බලන්න, right? Right? So ලස්සනට ඉතින් හදා ගන්න ඕනේ, right? So ඊට මෙඩියන් නැති වෙන්න. Right, anyway, like that you can see that you can basically, right, create like this, right? Even guys that you can just delete this thing if you need. Delete karna මේක මට ඕනේ. Let's say I just get some characters here. Let's say I just get a kind of character like this way. So මෙතනින් දානවා මෙයාව. Can you see? Right? ඔන්න මම character එකක් හදාගත්තා මෙහෙම. Right? So you guys can see, guys, that it's very beautiful, right? Right? Are you funny weather? Right? So like that, so there's no any meaning. මම මේක හිතලා හදපු එකක් නෙවෙයි. නිකම්ම මම create කරා, right? This is I just very simply created, right? As I want, that's it, right? So like that, guys, we can simply, right, create, right, different 3D objects, right, as we need. Right? So can you please, guys, type yes if you understood? So far I didn't ask this thing from you, but I thought that you guys have been, right, joining with this session, right? Can you please type yes in chat box if you understood so far things that I just explained? ඔයාලගේ chat box එකේ type කරන්න yes කියලා. ඔයාලට මේ තාක් මේ කරපු දේවල් පැහැදිලි නම්. All right. Okay, right. I think that you got my point, right? So basically, you can create a kind of object, right, as you need, like this, right? So you can just try, right? So you have to do at your home, right? Just creating these stuff. And this is how, guys, we can basically create kind of a 3D model. 3D model එකගෙන මෙන්න මේකට. Understood? So even මේකේ තව ගොඩක්ම කරන්න පුළුවන් පොඩි දෙයක් ඔයාලා පේනවා මම delete කරන්න, right? So let me just get a kind of a new shape. So I can't actually explain everything within this particular time, but I'll try my best to explain, right, some of these stuff. So you can just create lots of things here. Now let me just get this. Even you can just change the color, right, as you need. You can just click this one. Let's say I just want to get this thing with this purple color, right? So මේක ඔයාලා ගෙදරදී try කරලා බලන්න, right? You can just try this thing, right, and just get more idea. මම දැන් ඔයාලා පෙන්වන්න යන්නේ, I'm going to show you guys how can we basically create kind of a hole. දැන් මේ box එකේ සිදුරක් හදන්න ඕන දැන් අපිට. Now just think that you want to create kind of a hole here. කොහොමද හදන්නේ? It's very beautiful. We can very easily do it, guys, right? So you can see guys, in this particular, right, shape set, you can see here we have a shape like this. Maybe shape cylinder, not this one. I'm talking about this one. So this one actually, if I take it, right, it is different, right? It's basically, guys, this is actually taken to create the hole. You can see it's hole, right? You have to bring it, make a, right, you have to take it, right? Make a, first of all we have to right, increase the height of this, and then guys, and then you can see that me ලස්සට පේනවද දැකද hole එකක් හැදෙනවා, right? Can you see it? මේක අපිට අවශ්‍ය තැනට අරන් ගිහිල්ලා you have to move it to the correct place, and then you can just basically when මේ arrow එකකින් පහළ යනකොට මොකද වෙන්නේ? It is creating kind of a hole, right? And you can see, guys, that it's giving you like this way. It creates kind of a hole, right? Now the thing is, so now the hole was created, but now I want to remove this part, but hole right? Even we can just create, right, the size of the hole like this way. It's like this. Now the thing is, guys, right, if I want to actually create this hole here, I have to select this entire thing. And guys, here we have a button. This is called group. We're grouping here, right? So you can just click this group, and now you will see the, right, now you will see the magic. Can you see? The object hole. Can you see, guys? That particular hole was created. It's very beautiful, right? That's the thing, guys. So basically, මේක අපිට ගොඩාක් දේවල් කරන්න පුළුවන්. මම තව උදාහරණයක් පෙන්නන්නම්. Now let's think about so it can be anything, right? ඕනම දෙයක් වෙන්න පුළුවන්. Now just if I take let's take this one, right? දැන් මේ සිලින්ඩරේ මම ගත්තා. මේක මම මෙහෙම එකක් හදාගන්න, right? So I just created like this way. It's very beautiful, right? And I can just see this one. Even I can just change the color as we need, right? Let me just create this thing with green color, right? Not green. Let's create all right, this yellow color. All right, so I'm going to go with let's say let's go with black color. I think it's very nice, right? So I got this black color. Black color එකේ ඔයාලා ඉතර පේන්නේ නැහැ, පැහැදිලි නැහැ. ඒකයි ප්‍රශ්නේ තියෙන්නේ, right? Otherwise that හරි අපි අපේ blue color එකකින්, right? It's nice නේ, right? Now guys, right, now let's say what I'm going to do is, right, I'll just go here, then you can see that here that we have originally it has given you some Yeah, originally දෙකක් දීලා තියෙනවානේ. It has originally given you, right, two objects. But let's go with some different things. Right. Okay. So right. So let's go with some. Now let's say if I'm going to go with this n, right? I can just put this particular n here, right? It's kind of a right letter. So now let's say I just got this n here, and I can even right. Right. Change the size of this. And the place. Like that. All right, now guys, now දැන් මොකද මම කරන්න යන්නේ? මරු වැඩක් කරන්න යන්නේ, right? So I just actually increase the height of this. Like that. Then mama, right? You can see when I click this one, right? You can see it gives you something called hole. Evan, here also we have something called hole, guys. When I click this hole, you can see it gives something like this. Right? So what I'm going to do is, guys, now I'm going to create a hole, right, with this particular shape. I'm here. I just can you see? So make a mathematical hadagan, right, as you need. But I just explain what is happening here, right? Now, guys, what I'm going to do is the same thing. I'm going to select everything, click the group, and you can see, guys. Can you see? Academy? It's very beautiful. Arape. Inside that particular object, we got some kind of a hole with the right letter. I hope you enjoyed. Give me 1 minute, guys. Give me 1 minute. Right. I hope you enjoyed this, right? And you can see that here we can simply create, right? So I just explained, guys. I just explained some example, right? Mama example right? So you can actually create, right, any kind of a thing. So what you have to do is, guys, after you have taken this particular one more thing, I just show it to you, right? You can see after you have taken this particular object, guys, right? After you have taken this, you can basically export, right? When I click this, you can see it gives you, right? OBJ, these are different file types, right? You can see it gives you for the 3D printing, use these different file types. For the laser cutting, use this one. You can just click this thing and you can take that file out. And that particular file out, you have to put into what? Put into the whatever the 3D printing or laser cutting, right, option. Right. So we don't focus about here the laser cutting. We focus about mainly the 3D printing one, right? So we'll go with that. All right. Now, guys, I'm going to actually that here we don't have a 3D printing machinery. Otherwise, I could have shown it, but I'll just show some examples later, right? But now we'll see, guys, right, briefly, what is happening, right, in this process, right? So, as I have already mentioned, guys, after you have basically taken this particular 3D model from this CAD software, right, you have to basically separate this particular 3D model into what? Model into different slices. Because I mentioned, guys, these the entire object cannot be directly, right? Entire object cannot be directly, right, taken by the 3D printer, right? So you have to get them slice by slice. You will see it later, right? When I show that. So there are some different software. So I'm not going to show them here, but you can just check them. So one software is Cura, and then there's another technique, another software called Fuse Slicer, right? So likewise, so these kind of softwares can be taken actually for splitting or slicing these objects into different slices, and these slices can be printed, right? That is the next thing. How can we print? Right? Make a print karan ko. That is what here I just mentioned. So when I talk about these 3D printing, guys, you know that these things will be physically printed, no? They are physically printed, right? When these things are getting physically printed, guys, we need what? We need the materials for the 3D printer. So here I have mentioned, guys, some of the materials that we can use. We can actually use for this 3D printing. So we need plastics. There are different types of plastic: PLA, ABS, right? PETG, likewise, different plastic types we can use. And then we have to use some resins, right? Some if you want more high detail models, normally we use these resin 3D printers. And sometimes the metals may be needed: titanium, aluminium, stainless steel, likewise. And sometimes we may be needing some carbon fiber, ceramics, and biomaterials as well. So using these materials, guys, these machines are printing, right, whatever the model that you created from your CAD software. So there are different technologies. So I have mentioned those technologies, guys. There's a one technology called FDM technology, fused depositional modeling. Another technique called SLA, and then SLS, metal 3D printing, likewise some DMLS, SLM. So we are not going to discuss about these techniques in detail, right? But very briefly, I have mentioned, guys, what these techniques are, right? You can just further, right, go through them. For an example, that in the FDM or the fusion deposition modeling, guys, what happens that the melt plastic in the print, so basically the plastic will be melted and then prints layer by layer, especially good for the basic prototypes tools. And if you want to create some hobby models, that means for your fun, and these are very cheap and very easy to use, this FDM based 3D modeling. And this SLA, right? That is basically using the UV light, right? Ultraviolet light to harden liquid resin. Basically, if you want to get more high detail, smooth models, especially in the jewelry, dental tools, small parts, if you want to create, you can use this SLA technique. SLS, selective laser, right? Sintering. So basically, it is using some fuses powdered materials with the lasers. So if you want to create very strong, very working parts, very strong parts, if you need, you can use this mechanism, especially for the medical devices and for the machine parts, we can use this. And finally, the metal. If you want to get the metal-based 3D printing, you can use this, right? DMLS and SLM-like techniques. So I hope you got some kind of idea about, right, different types of this, right? So so I'll show you guys some of the examples, right, of this 3D printing to get a more idea about this. Wait a minute, guys. So now I'm going to show you guys kind of a very nice 3D printing example where a small car model is printed, right? I hope you right saw this one. So I'll show you another example. This is another very nice, right? It's a kind of baby Groot. You can see that how this particular output. So we'll see how this is getting printed. First of all, you have to design it, right? Make a design in like I designed in the Tinkercad, right? Okay, now we'll see. Now, one more thing, guys. Don't think this particular baby Groot is printed this much speed, right? You can see in this particular video itself, it has mentioned what is the actual speed. මේ මැෂින් එකේ ඇත්ත ස්පීඩ් එක මේ ඩෝන් ගාලා මේක print වෙන්නේ නැහැ. මේකට ලොකු වෙලාවක් යනවා. ගොඩාක් වෙලා යනවා. Sometimes the machine එකේ power එකත් එක්කත් වෙනස් වෙනවා. Sometimes it may be taking several hours. Understood? දැන් බලන්න මේකේ මුලින් පෙන්නනවා මේ what is the actual speed you can see. මේ බලන්න. ඔය ඊට පස්සේ පෙන්වන්නේ ඔයාලා මේක ඇත්තටම වෙන විදිහට අටක් ගාලා මේක පෙන්වනවා මේක. මේක මේ ලොකු වෙලාවක වෙන ප්‍රොජෙක්ට් එකක්, right? Okay, now see it. Right, I hope you enjoyed it. Right, so I'll show you another example. And this is a very beautiful example, right? Where the kind of right, several 3D animals, right? How they are getting printed.
Hi guys, Martin here. In this video I want to show you some amazing articulated 3D prints. If you want me to 3D print your name, just like the video and let me know in the comments what name or nickname to print.
All right. I hope, guys, that you now you got a very clear understanding about what is 3D printing, right? So this is what, guys, basically uh, uh, what is actually happening, right? What is happening in the 3D printing? So basically, we can create anything, right? Anything can be, right? Without having any issue, we can create anything, right, in the 3D printing. So I have already mentioned to you guys that how to create the 3D model. That was basically we discussed, right? So in that previous Tinkercad, so Tinkercad is kind of very simple, right, tool to create the 3D models. But there are guys lots of very advanced, right, 3D object creation tools are there. Understood? So that way then පෙන්නපුව ගත්තම ටික කැඩෙන් හදපුවා නෙමෙයි ගොඩක් ටික කැඩෙන් හදලා සමහරක් තියෙනවා. For example, that you saw that there's a kind of a name tag or a name tag that in the Tinkercad also we have what? We have letters. With the letters we can simply create as you need, right? So අපිට Tinkercad එකේ ඉතාලම ලේසියෙන් හදන්න පුළුවන්, right? We name වගේ. But if you want more smooth, more advanced stuff, there are some different tools, right? මම අර කලින් mention කරා වගේ, right? There are lots of tools, guys. For an example, that Fusion 360 SolidWorks. SolidWorks means kind of a very good software which can be used for building. Especially SolidWorks actually is used by some architectures as well, right? So architects as well, architects are also using actually that SolidWorks like platforms for building their basically some structures, right? Now the thing is this, guys. So after you have finished it, right? After this was finished, right? The object is removed from the printer, and you have to get clean all the unwanted stuffs, and then you have to cure and sand the surface for the better finish, right? So you saw in the videos also, you saw that one. So normally we have to do some, because that sometimes the thing, maybe you saw that there was one video, if you saw that particular baby Groot thing, the things were printed separately, not as a single bunch, right? Cali whenever print kare, and then finally they were getting connected likewise. So I hope you got some kind of idea about that part, right? Right, now some advantages are given. I have already mentioned, guys, the rapid prototype is lower cost and freedom to create complex geometries. You can create anything. That's why I just mentioned. You can just create even anything here, right? And you can customize without the expensive setups. You don't have to actually. Let's say if you have done this thing with the support of the humans, then guys, you have to spend lots of money. And then reduces the material waste compared to subtractive methods. And on-demand production, you can create as you need at any time based on the demand. Right, I hope you got my idea about this 3D printing. So this is how, guys, we can actually get something alive to a physical prototype to actually check the viability of the product. Right, guys, now I mentioned, if you remember, in the beginning of today's session, I mentioned I'm going to give you a surprise. What is surprise? Actually, this particular part was not initially included inside this particular lesson, but I just thought of giving kind of an idea about this one to you. What is that? Digital twins. And this is a kind of a more advanced version of prototyping, guys. It is basically the virtual copy of the real world. In the normal prototypes, right, we just get a kind of a let's say minimum viable product, right? And we see, right, how this product is connected and how this product is functioning. And even in 3D printing, we get kind of a physical output, but again, that's not the actual thing. But what happens here is, guys, we create a kind of a twin. Twin can count. New Sahodari, new same thing. Carbon copy, the same thing. But what is that? Digital. That means, guys, we are going to create the similar thing in the virtual world with the similar functionalities, similar environments, similar aesthetics. We create the things in the virtual environment to what? To test the functionality or the design, right? In a very realistic way compared to the prototyping. This is not actually like a prototype. This is the real thing, right? Let's say, for an example, let's say if you have a real car, if you have a real vehicle, right? What we create is, guys, digitally we create the same vehicle in the digital environment. Then, rather than just testing that particular vehicle in the physical environment directly, we can test that thing in the virtual environment because the cost, harm, everything will be very less. That is what here I have mentioned, guys. Right? So basically, digital twinning means creating a virtual model of the real world object, not just a prototype, guys. This is a real world product virtually. It looks and behaves like the real thing, just inside the computer's thing, guys. Not like a prototype. Prototype means a minimum viable product. But this is a real thing we create virtually, right? I will show you an example as well. Let's say, imagine you design a car, machine, or a building, right? With a digital twin, what you can do is you can see how it looks, test how it works, spot the problems before building the real thing, right? So here you are building the real virtual item in the physical object, right? It's a very nice thing. It's a very advanced cutting edge technology which is used in the world. So I have given, guys, the steps. Again, you have to here create the 3D model, the visual thing you have to create. But now it is not just the visual thing, guys. You have to do what? You have to add the real world data, real world functionality of that particular product. For example, let's say movement, temperature, speed, everything. If it is a car, let's say. And the digital twins behave like a real object, and you can test ideas safely in the digital world because it's not harming, right? For an example, now let's say you have built a car. The car again. Now let's say you want to see if this particular car hits a kind of a, let's say, concrete, right, structure. What will happen? මේ කාර් එක ගිහිල්ලා කොන්ක්‍රීට් මොකක් ස්ට්‍රක්චර් එක හැප්පුණාම මොකද වෙන්නේ බලන්න ඕනේ, right? දැන් ඔක ඇත්ත කාර් එකකට කරන්න කිව්වොත් එimhe harm එක වැඩිනේ, guys. But rather than doing that, you can just virtually create this and see the same thing. So it will give you a kind of idea about what will happen to your car. Then the cost, time, and the damage, everything will be very less, right? That's the thing. That is for the digital twins. I'll show you an example. So the advantages are given here. The test without breaking the real object, save the time and money, improve the safety and quality, making the smarter decisions. Very important. Right. This is the end of this discussion, guys. Right. So I hope you enjoyed today's workshop, today's webinar in a very enthusiastic way. But before that, I promised you, I'm going to show you a kind of a demonstration about the digital twin, right? Wait a minute, guys. Right, this is a digital twin of an airport. Within airport, digital twin connect. You can see that here everything is there. The flights and all the needful parts in the airport is there. Now we can just simply let's say rather than building the airport physically, environment airport right? $1 trillion we can just digitally create it and see how this thing functions. Everything can be checked. Right, now see it. You can see here everything, guys. Even that speed limit, right? All the distances, everything is given. I hope you understood, guys, right? What this particular thing means. So I think now, right, that is the end of today's session. So today, actually, I just discussed with you about the idea of this prototyping. Under that, we discussed about different prototyping mechanisms. We discussed about concept prototyping, and then functional prototyping, and then digital prototyping, as well as finally the mechanical prototyping. Under the mechanical prototyping, guys, we discussed about different types of doing the mechanical prototyping. One mechanism is CNC machining, and then we discussed about basically right, and we discussed about basically laser cutting, and then assembly prototyping with material testing, and we discussed about the 3D printing in detail. And under 3D printing, I mentioned you have to first of all design the 3D model, and then you have to slice this 3D model, and then you have to print it, and then you have to, right, do the final steps. And I even explained to you guys how can we model it, right? So we need kind of a CAD software. In today's discussion, I actually explained you how to work with the Tinkercad. Tinkercad software was introduced to you. So I think there's a kind of question also how to design it. You can use some test tools like you asked about the digital twins. I know for the digital twins we have different platforms. Even we can virtually program it. Or there are some advanced platforms we can just try, right? Which is combining with the AI as well. So, but it's not a kind of main focus in today's session. But I just mentioned to you there are some techniques like them as well, right? And then I explained about, guys, how can we use the Tinkercad. So I didn't actually explain in detail the Tinkercad, but it's a very simple platform. You can create any kind of 3D object. So you can basically right go there and practice, right? And then you can have a good understanding about that. There are lots of options, but I just mentioned Tinkercad is kind of a very simple, right, platform. You can go create more, right, advanced basically structures with some more advanced tools, right? So and then, guys, I explained about um, the digital twin, right? So I think there's a kind of question about that one. So yeah, so you actually, so I'm not going to actually discuss about the theoretical or the fact, the basically more advanced techniques about this digital twin here. I just wanted to give you basically the digital twin is kind of a virtual representation. You can just identify as a model of a real world object. So it includes not just the product, not just the physical thing. It includes not the physical, basically not just the design. It is including the entire functionality as well. So to create the digital twin, guys, we need actually, it is not a simple thing. We need the data first of all, and we have to gather the real-time or historical data from the sensors, machines, or processors, and then we have to basically create a kind of virtual model. So these models are highly mathematical connected models, guys, right? So these are replicators of physical structures as well. and then they are going to be connected to the real virtual real environments as well through the Internet of Thing. And then we can we have some right simulation platforms, for an example, that ARSIMS, and then Kala, likewise some platforms are there. So even it can be connected with the AI, right, with the AI guys, because that so the time is not sufficient, because I have, because one some of my university students have done lots of research projects, right, which are actually based on this digital twin mechanism. Basically, we have built, I'll tell you one example, that we built a kind of a mechanism to actually avoid the accidents when a vehicle is coming after a vehicle. So if the right the particular backside vehicle, let's say, it's getting hit to the vehicle, so there are some techniques that we can just try. So we mention them as rear collision. So likewise some techniques were built, and so they were actually built in these digital twin platforms, some simulation platforms. So the thing is, guys, actually that our basic machines, the computers, are not actually supporting to those platforms, because they need a very high computational power, right? A very big graphical processing unit power is needed, guys, to actually perform these digital twin like platforms, because it needs a very huge graphical support. So anyway, this is kind of a new technology at the moment in the world. But I just mentioned, guys, that there are some techniques like this. So we believe with these actually webinars, workshops, we believe you will learn these stuffs, and you will actually motivate yourself to uh, learn these stuffs and come to this IT field, and be right more advanced, right, productive IT people in the world. So I think this is the last webinar, guys, we conducted under this Future Founders program, which is organized by the SLESA with the collaboration of SLIIT. So I hope I have already mentioned what are the webinars that we conducted. So I hope you enjoyed, right, a lot within this session, within this series, and you learned a lot, I hope. And I must thank highly to the SLESA for actually encouraging us to do these kind of webinars, and to actually empower our Sri Lankan University, as well as mainly we focus about the school kids. So I hope that in this session also most of the participants are actually the school children. So I must thank on behalf of SLIIT actually to arrange and encourage these programs to you. So I think that the all of these webinar sessions actually will be available in the YouTube for your reference, and you can even check them and get more idea about these things and explore more, guys. So don't just, so we are just giving kind of a motivation only within a very small duration. So it's your duty actually to actually explore more and get more idea about these stuffs and learn more, and be more productive people to the world, right? So thank you so much for participating today's session, as well as all the webinars that we conducted. We conducted everything for your success. I hope you enjoyed it and got the full value of that. Right, then have a nice day, dear students. Wish you all the very best for you all the works. Right, good luck for everyone.